An atomic bomb explodes, and then the unimaginable happens. The sand melts, temperatures reach thousands of degrees, a pressure that shapes diamonds, and from this inferno emerges something that science has never before seen in the entire known universe.
Today we're diving into the nuclear inferno, and we're starting right away.
Who among you has seen the movie Oppenheimer, and what did you think of it? Feel free to let me know in the comments. A pivotal scene in the film shows the Trinity atomic bomb test, and it is precisely that test, decades later, that is turning the world of science upside down. If you find this kind of thing just as exciting as I do, why not subscribe to the channel right now? Every subscription really helps me a lot.
And if you've already subscribed, help the video out with a thumbs up. Let's try to hit 5,000 likes. The YouTube algorithm loves that. Thanks a lot, guys. So, it's July 16th, 1945, still before sunrise. The New Mexico desert, a place called Trinity site.
Engineers, physicists, and high-ranking military officials have gathered there to witness something humanity has never seen before: the first explosion of an atomic bomb. The Manhattan Project, the most secretive research program in history, is heading toward its final moment. Years of work by thousands of the world's brightest minds, all leading up to this one moment. At 5:29 a.m., someone presses the button. The countdown reaches 0. What happens next is hard to put into words. The bomb releases the energy of 21,000 tons of TNT in a fraction of a second. Temperatures exceed 8,000 degrees. A shockwave rolls across the desert like a wall. The sand beneath the detonation point instantly melts into glass. Copper wires and the measuring instruments vaporize on the spot. Everything lying on the ground at that moment is sucked into a seething fireball where normal laws of physics reach their limits. And precisely in this moment of total chaos, something happens that scientists now understand.
The molten sand solidifies as it cools into a greenish, glass-like material. It is called trinitite, named after this very first atomic test. And in this trinitite, enclosed like time capsules, are things that no one has ever observed before in the entire known history of science.
In 2021, a research team made a spectacular discovery. A so-called quasi-crystal was found in the trinitite, a type of matter that was previously thought to be impossible. Unlike normal crystals, in which atoms arrange themselves in regular, repeating patterns, quasi-crystals possess an ordered structure that never repeats itself. Until that moment, such quasi-crystals had only been found in meteorites, where they likely formed during the collision of two asteroids in the early solar system.
And now, at the core of a man-made nuclear fire. Incredible. But that's not all, because now, several years later, researchers led by geologist Luca Bindi from the University of Florence have discovered something even stranger, something that has never been seen before in the entire known universe.
A completely new type of crystal embedded in a copper-rich droplet deep within the trinitite glass.
It's a so-called clathrate crystal, and it was completely unknown until now. Not just rare, not just barely researched, but simply never seen before in the known universe. But what even is a clathrate?
Imagine a molecular cage structure. Atoms arrange themselves in such a way that they form actual cavities in which other atoms are trapped, like a microscopic prison cell made of silicon in which calcium, copper, and iron atoms are imprisoned. The cages themselves are 12-sided dodecahedrons and 14-sided tetradecahedrons.
Fantastic words for Scrabble that beautifully describe the three-dimensional shapes in which these atoms have arranged themselves. Luca Bindi explains,
it is the first crystallographically confirmed clathrate ever identified among the solid products of a nuclear detonation. What makes the discovery particularly interesting is that this clathrate formed in the same extreme environment as the unusual quasi-crystal. Both phases appear to have formed during the explosion under highly transiently unstable conditions, with enormous temperature gradients and ultra-rapid cooling. And now comes the crucial point. This crystal cannot be produced under normal conditions. No laboratory in the world can reproduce the combination of extreme pressure, extreme heat, and this unimaginable cooling rate. The crystal exists only because an atomic bomb exploded. It is a child of the apocalypse.
That would also be a good title for a novel. I'll have to remember that. Well, now you could say, clathrate this, clathrate that, who cares? So, what fascinates scientists about it so much?
Such phases, that is, such states of matter, are known as metastable structures. This means they could theoretically transition into a more stable state, but they do not because the conditions that allowed them to form were so extreme that the crystal was, in a sense, frozen in place, like a snapshot from absolute chaos. The team's calculations show that there is only a very narrow range of temperature and pressure conditions under which this clathrate could form at all. Even within this extreme explosion, it was a matter of centimeters and milliseconds.
Had the conditions been just slightly different, then trinitite wouldn't have existed. Instead, some ordinary mineral that we've known for a long time. G. Nelson Eby, geoscientist at the University of Massachusetts, who's already worked with some of the researchers involved, comments,
"The extreme yet transient conditions of the Trinity test allow for the formation of metastable phases that might not even be found in laboratory experiments. This is an interesting new addition to the clathrate universe." And the exciting thing is, Bindi and his team believe that while the quasi-crystal and the clathrate formed in the same explosion, they did so in slightly different locations. Wherever there was a lot of copper in this explosion, the quasi-crystal formed. Where copper was scarce, however, the clathrate formed. Two completely different materials, both children of the same explosion, emerged just a few meters apart. But what does this mean for science beyond this historical curiosity? Luca Bindi says, "This work underscores an important idea. Nature, and sometimes human events, can produce materials that lie far beyond the limits of conventional synthesis. Similar processes could occur during lightning strikes, meteorite impacts, or planetary collisions. These tiny grains trapped within the trinitite are, so to speak, snapshots of physics and chemistry under extraordinary extremes." And that is the truly revolutionary idea, because if such structures can be created by extreme events, whether by atomic bombs, meteorite impacts, or lightning strikes, then that means that out there in the universe, where collisions between asteroids and planets are commonplace and stars explode, materials may exist that we don't even know could exist yet. Every time something collides with enough force somewhere in space, a completely new material could be created that isn't in any textbook.
maybe there are planets made of pizza tray. I just made that material up, but I'd be very much in favor of it actually existing. And something else makes this discovery significant for material science. Because if we understand the conditions under which such structures form, we could theoretically look for new ways to technologically simulate such extreme conditions.
Then we could specifically create materials with previously unknown properties. So perhaps the materials factory of the future will work with impulses, pressure waves, and shock fronts. All of this shows once again that despite all scientific progress, we are still just scratching the surface. A small piece of greenish desert glass from 1945 still holds secrets that shake our basic assumptions about matter. And who knows what else lies dormant in other trinitite samples, gathering dust in some archive boxes, waiting for someone to take a closer look.
I'll keep you updated on all further discoveries. So remember to subscribe to the channel so you don't miss anything, and we hit 400,000, and hit that thumbs up button now so this video can break 5,000 likes. And while we're on the subject of extreme natural events and their unexpected consequences,
in the next video, we're switching planets and heading to Venus. The Soviets sent several probes there, which provided us with incredible images of the surface. And here's the kicker. Scientists have just discovered that some of these probes might have survived to this day. You can find out exactly what's going on there and whether we can locate these probes in the video shown in the top right corner. As always, check out another exciting topic about science and space in the bottom right corner. Otherwise, I'd say see you in the next video. Take care, everyone.